In this presentation, we want to introduce the concept of present value. The first image we want to have in mind when considering the concept of present value is to have two time frames, two time periods in which we have the same dollar amount. So if we have the same dollar amount given to us either now or at some point in the future, which would we rather have? Typically, most people, if we're asked this question, would we rather have our dollar today or our $100 today, or we would rather have it in the future, would say we would rather have it now and want my $100 now. If we were to ask why you'd rather have the $100 now than in the future, you might give some reasons such as, well, I want to use it now. I have things that I want to buy now. I have costs that I want to pay for with that $100 at this point in time. You might also get some answers such as, well, the future is a little bit risky. How do I know you're going to give me $100 at some future point in time? The bottom line is that the $100 today is worth more to us than the $100 that we may get at some future point in time. We could then ask the question, well, how much would we have to give at some future point in time for these two amounts to be equal, for us to value the $100 today equally to the amount that we would receive at some point in the future? In order for these two amounts to be equal to us in value, the future dollar amount, if we were to receive money in the future, would have to be higher than the current dollar amount. In other words, for us to make the decision to accept future money as opposed to today's money, we would expect that the future money is going to have to be higher. It's going to have some higher dollar amount. So that's the first kind of image we want to think of when considering the present value of money. We typically think that the present value of the money is going to be worth more, is higher than the future value. So if we have the same $100 today, same $100 at a future time, the today's $100 will be worth more. If we want even amounts to us, the future value will have to be a higher dollar amount in order to be worth the present value to us. There are a few reasons for that. One is just the fact that the value of the dollar will go down. So the value of the dollar will decrease over time. That's due to inflation. Inflation is generally between 1 and 5%. So we can purchase less stuff with those dollars. That's one item that will decrease the value. The other is that there is usually some risk, and or if we had the money today, we could invest that money someplace else and get an investment or a return on it. And therefore the value would be greater today because we could use that money to either generate more money or get value from it by spending it. So if we had it today, then whether we spend it or not, it would be doing something for us. It would be working for us in some way, and that would be another factor that would increase the value today as opposed to a future value. For us to think about this numerically, then we would have to think about some type of interest rate we would apply. This is going to be the formula that we'll think about with regards to present value. So when we think about present value formulas, we're thinking about a future value out here. We have a future dollar amount that we want to bring back to present values. This is going to be important for capital projects because typically we're going to talk about outflows or inflows that will happen in the future. We're going to get money in the future, let's say, and we need to bring it back to today's dollars so that we can measure them as of today's dollars. So we're going to get future outlays. We're going to have to measure them in today's dollars. So whatever the cash flow that we get 5 years from now, if we bring it back to today's dollars, is going to be worth less as we compare them to today's dollars and compare our investment to the cash flow. So here is our formula. P equals F over 1 plus I to the N. We're not going to spend a whole lot of time working a lot of problems with the formula, because in practice and in schools, we often use other methods such as annuity tables or Excel to calculate these formulas. So if you're in a class, you may want to ask, are we going to need to know what the formula is and calculate with the formulas, or are we going to be using tables? We'll take a look at these different ways to calculate the present value for a few different reasons. One is that you want to be able to see them in these different formats, know that they're not going to be different animals altogether. They're not different things. They're all the same thing, they're just different formats to calculate it. When we go to the annuities, again, most schools don't require you to calculate the annuity with the formula, but give you other types of calculations so you can put your mind to other types of things, such as the concept of capital budgeting. And when we move to Excel, we'll often use the formulas as well, and the present value of annuity formulas will be very similar, as we will see. If we consider this time frame to be 1 year, and we say that the future value, we have 220 future value, that's how much we're going to receive a year from now, and we plug this into our formula, P equals 220 over 1 plus 0.1, 10% is going to be our rate to the 1 for 1 year, we're going to get the 220. And if we want to prove that type of calculation, we could say, all right, let's reverse this. Let's say this is our present value. Multiply that times the 10% rate. That's going to give us $20. The 200 plus the 20 is going to give us the 220. So we can kind of prove our calculation. If we wanted to see this for 2 years, let's say this is a 2-year time period then, and we plug our numbers into our formula, we're now going to say that the future value is 242 to make this consistent. So the future value is 242. We want to present value it. So 242 over 1 plus 0.1 to the 2 for 2 years, that's going to give us $200. So if we see that in terms of our thought process, we can say, all right, if we had the 200 starting with, and we went through 200 times 10% is 20, plus the 200 is 220 for year 1. Year 2, 220 times the 10% is 22. 22 plus 220 is the 242. So you can kind of see how this is being worked together, how we can see this calculation formatting. That's how we would take a look at it in terms of a formula. More common in schools is to use the charts. So when we think of a chart like this, there's typically 4 of them. 2 present value charts, 2 future value charts. The reason they're very useful is because they don't require us to do the formula. Most of the financial accounting and managerial accounting is more concerned with our decision-making process than the math involved in the formula. And when we go to annuities, the math, like we say, gets a little bit more complicated. It's easier to use the charts, and it's going to be more the way we're going to be doing it in practice typically. You can also use a calculator that's very simple and therefore don't need any complex calculator that could do other things on a test that possibly schools don't want. Therefore, we use charts instead of calculators and instead of Excel in school. Obviously, in practice, Excel is probably the best way to go, and we'll take a look at that in an example shortly. So the chart, remember there's 4 of them. You want the present value charts. We're currently looking at the present value of 1. So 1 number in the future, we're pulling back to the present value as opposed to a series, an annuity. So if you have a series of payments, that would be an annuity. The other way you can think about it is, of course, that these need to be, you could see they're all less than 1. So, and that would make sense because, of course, if we're pulling a future value number into the present, it's going to have to be less than the future value. So we're going to multiply times something less than 1. The rates will be up top. The periods on the side, on the left side, we're looking at 10%, and we're looking at 2 years. So 10 and 2 years. Now, these periods could be in years. They could be in something other than years. Just note that the years need to coincide with the same rate. So in other words, we usually think of the rates in terms of years. If we were thinking about a monthly rate, we might have to take the rate divided by 12 so that we get the periods and the rate will line up together. So now we've got the 0.8264. So the 0.8264, if we take the 242 times 0.8264, that's going to give us our 200. That's typically the format that we will use in many test questions. Normally, the question will be asking us for the present value when we're considering a present value calculation, but it's possible for us to have this formula and be looking for something other than the present value. So normally we'll be solving for present value, but we could be solving for the interest rate. So if they give us, in other words, the present value, and they give us the future value, and then we might solve for the missing factor in that case, which would be the interest rate. Or it's possible that we might be solving for the number of periods. So they could give us all the other data, and we would need to solve for the number of periods. To do that, we could use a formula to do that. It's possible to do that with tables, and we'll show a function to do that within Excel as well. So Excel is the third way and the best way to really look at this same type of data. So we've looked at it in terms of a formula, we've looked at it in terms of tables. Now, Excel is usually the way that we'll see it in practice, and we really want to know within Excel the present value and the future value formulas. So we'll take our same data up top. We have the periods 2, the future value 242, so we're imagining we're going to get 242 2 years in the future. What's the present value at a rate, discount rate, the 10%? Given that data, we could go into Excel, we can go into the Formulas tab, we can go into the function library, the function library group, and then we can insert function. Insert function is where we can search for different functions. So if we type into this field, we want present value, we're looking for the PV. And after a while, you should get used to just present value PV. That's what we're going to use. You're going to see it in references all the time because that's often the shorthand, present value PV. So that's the formula we want. If we select that, then we're going to have a formula dialog box, which will help us to process this formula. So the rate is the first item we need. It's going to be B4. It's in cell B4. So B4 is 10%. And then the number of periods is the next item we need. That's in cell B2, which is going to be the $2. So it's in cell B2. The payments is 0. That's the tricky thing with this because we're going to use the same PV formula for the present value and the present value of an annuity. And therefore, we'll use the same fields. The payment means annuity payments. And there are none because we're not making systematic annuity payments. We'll take a look at annuity payments in the future. Therefore, that's 0. And this one, notice how it's not bolded because it's not used in every function. This one is going to be what we use in the present value of one function, which is in cell B3. B3 is the amount of the 242. So that's what we're going to have. It actually gives us the answer. It's going to be 200. So we can see the answer down below. And then once we enter this into the field, we'll get our answer. And this is the way we would see it if we wanted to just type it in as a function, which once you do it a few times is pretty nice to do. It's a little bit quicker. I'm going to say equals and we say negative because it'll flip the sign. If we don't put a negative, it'll come out as a negative number. If we want to make it a positive number, we could put a negative before it. PV brackets, and then notice this little dialog box down here that helps us to work through it. So when we're on B4, it's going to say that's the rate. We're looking for the rate. And so we're going to say, all right, B4 is the rate. So that's up here, B4, 10%. And then when we say comma, that just means the next function, which is in PER. That's this item. It says we need that. That's the number of periods. So it's 2. So 2 is in B2. So that's in B2, number of periods, comma, to the next function. And then we have the 0 because we manually entered the 0 because, again, that's an annuity payment. This isn't an annuity. This is present value of 1, comma. And then we have the future value, meaning this is the amount that we're going to get in the future that we need to present value. So there's the 242. That's picked up in cell B3, the 242. And so that's going to give us, if we hit enter, that'll give us our function, which will be the 200. Now, we also want to show this other information that will be the goal seek. Remember, we said that it's possible that we have all the data except for the interest rate or all the data except for the number of periods. And then if we have all the factors except one, we could just solve for that missing factor. We could do it with the formulas. In practice, it's nice to know the major formulas, which is going to be the present value and the future value. And then we could use a tool called goal seek. Instead of memorizing 3 formulas for every possible unknown in these functions, we can use the one formula, present value, future value, and then use goal seek if we need to solve for any other item. And that's one method that you can go through this, and that will simplify at least the amount of things that you have to memorize when you think about these types of problems. So how would that work? Well, if we had this data, let's say we had the periods, we had the amount, and then we don't know the rate. Let's say we know what the present value is, but we don't know what the rate is. So this is the one factor we don't have. We could plug that into the formula and then solve for the missing factor. Or we can basically tell Excel, I'm just going to guess a rate here. I'm going to put whatever the rate is here. And then I'm going to put our formula. This is going to be the PV formula here. And then we'll just tell Excel using goal seek. And I'm just going to explain it here. And you can go to the practice example problems where we'll actually do this in Excel. You can use goal seek and say, hey, goal seek, Excel, I would like you to change this cell to be what the answer is, 200, by adjusting the rate. And because there's a formula in here that takes into account the rate, it will then figure out what the difference should be. In other words, it'll test whatever this cell needs to be in order to make this cell what we told it to be 200. And it'll basically work that problem out. So that's one way we can basically solve any other factor, any missing variable, using only one function, one equation within Excel. And we could do that here too. Like if we don't know the number of periods, but I know the amount, I know the rate, and I know this is 200, then I can say, well, let's use the present value formula. I'm not just going to type 200 in here and then look for a formula up top, because I don't know the formula for the number of periods. I don't want to know another formula. I just want to use the present value formula to figure out the number of periods. Well, I know this is 200. I'm going to put in the formula for present value here. And then I'm going to use GoalSeek and say, hey, Excel, would you make this 200 by changing this cell? Do whatever you got to do to that cell to make it 200. And it'll obviously pick 2 years in this cell in order to make that 200. So that's going to be one useful tool. The reason we want to go over this, and again, you could take more detail on that in the example problem where we actually show this within Excel, is that by doing that, you can memorize basically one formula. The present value function, this function, this box, present value, the PV, will be used for the present value of an annuity, and then you can also use that same formula to solve for the interest rate or the number of periods without having to learn multiple different formulas and functions with the use of GoalSeek. It's also very useful in many other areas.